Hello and welcome to the Design for FDM Technology webinar series. It's a pleasure to have you all with us here today. We would like to give you a quick and precise overview of quite a complex topic, which is designing for FDM technology. And you may wonder, hey, with 3D printing or additive manufacturing, I can print whatever I design. But of course, there are some pitfalls and some restrictions and best practices that we'd like to convey with you. As a reminder, this is our first session. Today we're going to talk about the basics, or as I would call them, the fundamentals. Really, these are the things that you need to understand um, um, basically from A to Z to get the most out of your FDM printer. And next week on Monday, same time, we're going to talk about some design considerations when really designing a new part from scratch. And then the Monday after, July 6th, we're going to talk about the advanced FDM functionality with different tools and best practices to share those. So this webinar series, all these topics, they build upon each other. So we do recommend that you attend all of them if you can and find it worthwhile. If you have not received all the registration links, you can see them on the right-hand side in the handout section. You can download those again. But before we begin, just a couple of things. You have noted that you are joined in listen-only mode, but that doesn't mean that we don't want you to ask questions. So please feel free to use the question tab you see on the right, or to raise your hand. And at the end of the webinar, we'll also host a Q&A session with you. But who's actually talking? My name is Stefan Schuster. I'm your host for today's session. I'm in charge of knowledge and training at Stratasys Europe. But more importantly, basically, Carolus Gedvanis, our expert, is on the line. He's our knowledge and training lead, also for the EMEA region. Carolus, can you give us a brief background on your experience and what we can expect from today's session?
Hello, Stefan. Good afternoon and welcome to everyone who joined this webinar session. So as Stefan mentioned, my name is Carolus Gedvanis. I'm Knowledge and Training Lead at Stratasys EMEA. I have 6 years of experience in additive manufacturing industry, working in different positions such as customer support, trainings, and also applications. And today I will introduce you with some fundamental considerations when designing and printing your CAD models.
Sounds very interesting. So I would say let's dive right into it. Thank you very much, Carolus. Like I said, pleasure to have you here with us. And let me just change the presenter to you so we can begin with the fundamentals today.
Thank you, Stefan. So I will share my screen. Before I begin, I would like to tell some opening words, and I think it is essential for every CAD designer, CAD design engineer to know the technology they will be using to manufacturing the design parts. Additive manufacturing gives you quite high design freedom, but like with any other manufacturing methods, there are rules and guidelines. So on this session, I will cover some rules and guidelines for FDM technology specifically. Common ways of getting your parts manufactured, one of them manufacturing in the office by yourself. This probably is the best way because you can control the whole process yourself, or sometimes you send the CAD data to Service Bureau to print the parts for you. And knowing the machine, how machine operator will process and print your model gives you an ability to communicate exactly what you need and even adopt your CAD design to make the process easier and faster for everyone involved. So for agenda today, I will speak about FDM process itself, a little bit about file formats. I will go into some considerations for part orientation. Then we will speak about how the machine works and what needs to be considered, like slicing height and toolpath. how it affects wall thickness, and in between I will do a short live demo with our software GrabCAD Print. Before we start, I would like to know my audience a little bit better and to ask you a question: how familiar?
So I think we lost Carolus for now. There seems to be a problem with the audio connection. But let's move on with the poll. It's basically a question: how familiar are you with the term design for additive manufacturing, or DFAM? There's three answer possibilities that we have. Novice, you've heard about DFAM and would like to understand more about it. Intermediates, you're already a CAD designer or a printer operator trying to improve the quality of your models in FDM technology, or you're an expert, meaning you're already a professional design engineer, but looking for ways to improve the workflow of the design process when creating models to be printed specifically with FDM technology. So let me just start the poll. You now see a window. If you are in full screen mode, you will not be able to click. So in order to be able to participate, please exit the full screen mode for now.
Stefan, thank you very much for jumping in for me. Apparently, I have a little issue with my connection.
Good, let's give it 5 more seconds. We already have a lot of answers. There we go. Let me just share the results. So basically what we see, it's a picture where we have some novices, some experts, but most of you are on the intermediate level. That's good to hear and very helpful. So let's see what we can all learn today.
All right. Thank you very much, Stefan. Just a quick question. Do you hear me? Correct?
Yes. Yep.
Okay, that's
now
fine.
We can hear you again.
Perfectly. Thank you for covering up. So next, first of all, we will speak a little bit about FDM process, and it is important to think about every step in FDM process already when designing the CAD model. So you can save time for everyone involved in this process. As a next step, after designing a CAD model, you have a so-called tessellation. We will jump into it a little bit later. Then we have a next step, print preparation, which is done by the software. Next step, we have a printing of actual model layer by layer. And the last step, but not least, is post-processing. Some people tend to forget about the post-processing, which can also involve such things like support removals or anything to addition like sanding and painting your parts. So as a CAD designer, you need to think all about the whole process. And we will start with tessellation today. So when we speak about tessellation step in the FDM process, we need to understand what so-called STL file format is. STL, standard triangle language, or in other words, it could be called standard tessellation language. And during this tessellation step, CAD software converts the surfaces of the model into smaller triangles, like you see in the image on the left side. Depending on the tolerance, which is the distance between the original CAD contour to the nearest triangle, tessellated model can be still not as accurate as the actual model. Also missing some of original CAD data, like information on multiple bodies, component structures, colors, and textures. And depending on what you need from the file, this is a problem which creates tessellation step. Also a problem is as you trying to get a better quality out of the file, you will reduce that tolerance, or in other words, you will increase the resolution, which will increase the number of triangles and also increase the file size. So if you have scan models, for example, they have usually very high number of triangles and have a huge file size, which also result high resource consumption of your PC or laptop. With Stratus's print preparation software GrabCAD Print, you can directly import native CAD files from your CAD software and skip the tessellation process entirely. There are around 20 file types to choose from, depending on CAD software which you are using. So for every CAD design engineer, you can find something appropriate. Additionally, you will have more accurate data and possibility to edit some of the model features, which we will cover on the last part of this webinar series. So make sure you tune in till the end. Getting back to FDM process, we can now skip one step and jump right into the print preparation. And we do this with our software. When talking about print preparation, one of the first steps the operator will do after importing the file is orienting the model on the build tray. So the simplest orientation for the operator who will be manufacturing your part might not be the suitable for you as a design engineer. And depending on what you expect from the printed part and knowing some basic orientation considerations, you may adapt your model to fit both of your needs. So first orientation consideration is printing speed, which in most cases is first preference for the machine operator. And here I would like to ask your opinion. If you look at these two images and tell me which orientation the parts will be printed faster. Is it the first one vertically positioned, or is the second one horizontally positioned?
Very
Stefan,
good.
if you can open.
Let's start the poll again. There we go. And again, if you're in full screen mode, you won't be able to click the poll. So let's give it 10 more seconds. Very good. And let's close it. Let's share the results. Perfect. So most of you, over 80%, are saying that image 2 will print faster. Is that correct, Carolus?
It is completely correct, and for those of you who chose the second image, they're correct. But why is that? So because printer head is moving faster parallel to X and Y axis than the build platform, waiting for each layer to be finished and moved one step down in Z direction, we will most likely have faster print time while orientating the model to keep the Z height minimal. Right.
So does this mean, Carolus, that the print is quicker because we've got less layers?
Exactly. The least amount of layers we have in Z direction, it will be printed faster because we don't have the less amount of layers you have, we don't have to wait until the build platform moves down and continuing our work.
Okay, and we also got a question from the audience. Does the support material actually influence the printing speed as well?
Very good question, and I will cover it on my live demonstration of GrabCAD Print, but for sure support structure, depending on the angles you have, will also affect the speed, the printing speed. But I will talk about it a little bit later when we get into the live demonstration.
Perfect, thank you.
So when we go into second orientation consideration, it is the surface quality. And the surface quality might be a requirement for you as a design engineer. So without giving any explanation, I would like to ask your opinion, looking again at the same two pictures, telling me if it's left printed vertical or right printed horizontal would give you the better surface quality of the model.
Good, let's start the poll again. Give it 10 more seconds. Three, two, one, and let's close it and share the results. So what 75% are saying that the vertical one will have the nicer surface finish. Is that correct, Carolus?
It's absolutely correct. So the first image, the vertical position will give us a better surface quality. But why is that? So let's jump into the next section. And this is the same model printed in two different orientations, as you see on the right side. And at the top, we see curved surfaces was printed perpendicular to z-axis, meaning that the layer lines will create a so-called stair effect on each step of the curve. At the bottom image, we see curved surface printed parallel to the axis, giving much better quality when the print head is moving smoothly in X and Y direction. So if you have some curved and angled surfaces, make sure you build them parallel to the axis. And the next consideration for today is the part strength. Again, I would like to ask the audience to look at the left and right image and tell what do they think. Given the geometry, which part will be stronger?
Okay, let's launch the poll again. Very good. 5 more seconds. And let's close it and share the results. So we're saying almost 90% of you are saying that's image 2 horizontal, and that will be the stronger buckle. Carolus, what do you think?
Very good. It's correct. So almost everyone answered correctly. The part printed, especially this geometry printed in horizontal position, will have the stronger clips. But why is that? So layering process gives us so-called non-isotropic parts, meaning they have different strength in X, Y, and different strength in Z-axis. So every bond between the layers is considered as a weak spot, like this. And to explain it a little bit better, if you see on the top left corner, you see the layer lines being pulled apart, which will probably, due to the weaker bonds, will pull apart. On the top right corner, you will see that the layer lines are compressed, and this will be probably better variation. Different orientation on the left side, if you see it is pulling along layer lines, will give you a better strength, as with the same if you are pushing or compressing against the layer lines, which will probably break. So to summarize all this, basically, if you are looking for speed, which is operator's first choice, most likely minimize the height for fastest build time. Surface quality, curved or angled surfaces should be built parallel to the axis, and strength layering process means strength differences in X, Y, and Z planes, or in other words, parts are not isotropic. To give a better example, I will turn on the GrabCAD Print software, and on the build plate we have a very, very simple part to give a better explanation. So orientating the part, this will be probably the first thing what the operator will do after importing the file. And on the right side you have some choices. You can choose the different angles, how to orientate the part. You have a selection to orient face to part. If we have a flat surfaces, it will be the best to orientate them directly on the build plate. And by clicking the surface, you can choose in which orientation to position that surface. Also, we have an option to auto-orient. So by auto-orient it, the software will place the part automatically, and you don't need to go through all those options.
So Carolus, we just learned about the different considerations like part strength, speed, and quality. If I use the auto-orient function within GrabCAD Prints, how does it do that? Does it orient for strength or speed or quality?
So in basically, software, and this probably could answer the question from the audience, will try to look for angles which will be supported and orientate the part which would minimize the support structures being built on the build plate, which also means if we have supported structure, then it will be printed longer. So in some way it can be said as speed, but actually in the background the software would check for any support structures being built and try to get rid of them.
Okay, thank you. So basically, depending on the application and how I want to use the part, I am asked to also check if that's the right orientation. So don't only trust the auto orientation, right?
Exactly, and I will show you some examples right away. So if we orientate the part like this, and we estimate our times, I will show this just in printing speed. You see that the print time is about 5 hours 48 minutes, and we use quite a lot of support material, which will be printed underneath those two overhangs. If we change the orientation, like it was suggested by GrabCAD Print software, and estimate the time, we will see that the print time becomes 2 hours 37 minutes. So it's almost the half of the printing time what we saved just by orienting the part a little bit differently. However, we learned that it's good to have the Z height minimized and put the part as flat as possible. And if we look at this example and estimate the time, so it's only 2 hours and 17 minutes. So with this simple example or simple geometry, we are already saving 20 minutes of time. And if it would be more complex geometry, we would probably be saving a little bit more. But let's go to the different example and modify this part just a tiny bit. So we added this additional block here. We have this part as flat as possible, and we estimate our time. You see it's around 3 hours 2 minutes. Just remember this time, 3 hours 2 minutes. If we put this part upwards, meaning that we increased our height, but we minimize the support generation, which will be right here on the angle, and estimate our time, we save a half an hour of printing time just by getting rid of support structure. So it's very important when you're designing, trying to minimize those support structures, which we will be learning on the next session. But if we say that our consideration is the strength of this part, and particularly looking at this position, we don't want that this block would snap. We would like to orientate this part like this. So the angle would be like this. And if we show slice preview on this part, you will see that along this potential weak spot, we have one single contour around it, right? We have one single contour around it, and it will make this part or the probability of this part snapping is a little bit less. Instead of having all those different layer lines as a potential weak spots aligned in this direction, in X or Y direction.
A quick question from the audience, Carolus.
Yes.
There's a question if we can manipulate the contours or the seams within GrabCAD Print, like we can also do it with Insight.
Yes, we can do that, but we can manipulate, increase or decrease the contours. We can change infills, and this is actually what I will be talking in the third section by showing you advanced features on GrabCAD Print and how we can influence the part post-CAD designing. So I will be showing that. Make sure you tune in also for the third session. So this possibility exists.
Thank you.
So the next part, or the last consideration for today, we modified this part just a tiny bit further and added some curved lines here. And as a CAD designer, we would probably like to have this surfaces as smooth as possible. And per rule, we need to have curved lines parallel to the axis. If we would slice this model and see the graphics, you will see that along the surface is nice and smooth. And to give you an example of how it could look differently, what I was talking about, the stair-stepping effect, it would probably make no sense to print it like this, but you can sometimes have surfaces like this on the top, and sacrificing time a little bit. If you look at the top layers here, you will see so-called stepping effect, like here on these slides. So these are basic design considerations or orientation considerations which can be influenced by operator, and you need to understand and communicate to the operator when you are sending the part to be printed. So let's get back to our presentation. Further on the FDM process, we have the actual printing model by layer, printing model layer by layer, and let's see what considerations do we have here. So we begin with so-called slice height, and the distance from the tip or nozzle to the previous layer is what we call this slice height, or in some other words, it can be called layer height. It is selected by machine operator and may require installation of the correct tip or nozzle, depending on the machine model. We have 4 different slice heights to choose from, depending on the requirements for the part. They will influence printing speed, surface quality, and strength of the part in some cases. If your model requires post-processing, such as sanding and painting later, you would like to have it printed with the finest possible slice height. It will increase print time, of course, but it will save a lot of manual work while sanding and trying to hide those layer lines. Next, we have a toolpath. So toolpath is single extrusion road coming from the tip or nozzle, and the width of the toolpath is determined by the speed of the drive gears feeding the material into the tip, like you see in this animation. If you want to have a thinner toolpath, or if we set the thinner toolpath, the drive gear will turn a little bit slower. And if we have wider toolpath, the drive gear will turn a little bit faster. In most cases, default toolpath, without messing around with any settings, is 2 times the chosen slice height. So why do we need thinner and thicker toolpath? It depends on the geometry what we use. If we use small details, we need to fill thin features and have a better surface quality. We use thin toolpath. If we are considering printing faster and also have a little bit stronger parts, we will use wider toolpaths. Default is a good combination of both speed and infill for thin features. And this comes all to the wall thickness. Slice height and toolpath together play a role to the wall thickness, and every wall is printed with at least 2 roads, or as we mentioned before, toolpaths. It is recommended to have minimal wall thickness 2 times the toolpath width, where default toolpath width is also 2 times the slice height. So recommended wall thickness will be 2 times because we have 2 roads around it, around the thin wall, and default toolpath width is usually 2 times the slice height. So without giving much thought into that, to summarize from the table, by using default toolpath width, it is recommended to multiply slice height if you know, or if you tell the operator the slice height, by 4 to get the optimal wall thickness. Due to the possibility to change default toolpath thickness or width. You can have lower minimal wall thickness than the recommended. However, it will be an additional step for operator to get them printed right. So it might need, if the operator doesn't check your model well and go through every layer looking at that it's correct, it will may result some issues.
So, Carlos, what happens if I have a file and load it into GrabCAD Print that does not apply these minimum wall thickness? Does the software tell the operator, hey, something is wrong here, or how does it work?
Very good question. So if designing thinner walls, they're like this thinner walls as recommended, there will be an overfill. In other words, toolpaths will overlap, so it will go 2 times over the same space, and walls will be thicker, and part quality can get much worse. If you design the walls thicker than using default toolpath width, it might give you such a small gap in between because we use default toolpath width, and it may be that your walls will be quite weak by having a gap inside it.
Okay, understood. So it's important to check also the wall thickness. Good.
Yes,
Thank you.
that's correct. Same rules apply to varying wall thickness along the X and Y plane. So when using fillets, adjustment for inner and outer fillet to keep the wall thickness constant is recommended. So for example, in this example, we have varying wall thickness, and to correct it, we have one wall thickness of 1 millimeter. We use inner fillet of 3 millimeters, so we would like to have the outer fillet of 4 millimeters. Next, we have draft angle. If you've been designing for injection molding, you may be used to draft angle, and if looking from the side, the walls look something like this. But it's not required to have them for FDM technology. So you can have, as we learned before, or should design the straight walls if possible. Looking a little bit closer, when having 2 default contours, software will try to close the gaps by adding additional toolpath in between. And if the gap is thinner as default toolpath, it will leave the gap inside empty, giving you a less strength for the part. If it does not fill by the width, it will leave empty gaps, as I mentioned, and for this, you can use so-called variable width fill option in the software, which will adjust the thickness of the toolpath for each layer to fill the gaps. However, if you are working in aerospace industry, rail industry, or basically any industry which requires some certifications, and by certifying the parts which will be built into planes, trains, or also cases cars, most likely you will have to print the part using default options, which is giving for you. And using something variable will not fit for certification. So this is also additional step for operator, and by checking the part if all the gaps are filling. So it is usually better to apply the rules we have learned to have consistency on your parts. And last but not least, we have fillets for ribs. In this example, we have a rib with a thickness of 1 millimeter. And you see that if we add a fillet of 0.5 millimeters, it will create a gap or empty space in between. So make sure you use the same thickness for fillets as you have the wall thicknesses. This rule applies for ribs in XY plane and not for the Z plane. So to summarize our webinar, it's better to use native CAD files when working with GrabCAD Print software. It gives you much it gives you better data and much more information on the part itself. When you're considering part orientation, or you're talking with the operator, or you are operator yourself who will manufacture the part, consider three things: speed, quality, and strength. So minimize Z height and support material for the speed. Print curved and angled surface parallel to Z-axis to get a better quality. And FDM parts are non-isotropic, which means you have different strength in X and Y and Z axis. Slide height affects toolpath thickness, and the toolpath thickness affects minimal wall thickness. So if you know, the slice height will be used for printing, adjust your wall thicknesses accordingly, or you can tell the operator to use a certain slice height. And also try to avoid varying wall thicknesses altogether. So thank you very much for listening me on this session. And for next session, part 2, we will have design considerations. So we will talk about self-supporting design, self-supporting angles, vertical holes, use of chamfers. I will show you a small example with SolidWorks software. We will talk about sectioning parts, assembling moving parts, and go a little bit into using threads and inserts for the part post-build. Thank you very much.
Thank you very much, Carolus. Very interesting indeed. I just want to show you, if I can move to the next slide, if you want to learn more, like I said in the beginning, please do register for the upcoming sessions where we'll go into more details about more of the expert topics that we have on Design for FDM. But also, I want to encourage you to register to our Stratasys Academy, which is our online learning platform for Stratasys. It's free for all Stratasys users, so just register and you'll get access. And here you would also find the webinar recording and the presentation from today and the upcoming meetings. If you are interested to learn more and kind of prepare yourself for the next session next week, we do recommend that you look at the Design for FDM learning program, which is a learning program that consists of different learning items, like some e-learnings, for example, on production parts, but also some tutorials on, for example, how to create variable density parts, and also some documentation. For example, we have a lot of things on FDM best practices, for example, how to orient for strength, speed, or surface finish, like we heard of today. And additionally, of course, if you're rather new to the topic, we have a lot more to cover here, like things like the FDM technology basics. How does it work? What are the systems that we offer? And also getting started with GrabCAD Print. If you haven't used GrabCAD Print yet, basically feel free to just download it and try yourself and see how actually simple it is to print your first parts. With that, thank you very much for joining us this afternoon, and I'm very much looking forward to hearing you again next week on Monday, same time, when Carolus will walk us through the design considerations. Thank you and take care.
Thank you very much from me, and I hope to see you at the next session. Have a nice afternoon.